And last one, temperature variation. So any semiconductor device, it is going to have a dependence on temperature. So that is unavoidable. And there are two primary temperature dependent effects in MOSFET. One is threshold. The threshold voltage is a strong function of temperature. So in BJT, the base emitter voltage have a temperature coefficient similar to the when the temperature is going to increase, VBE will decrease at the rate of minus 2 millivolt per degree Celsius. So for 1 degree rise in temperature, VBE will reduce by minus 2 millivolt. The same similar sort of behavior is found in MOSFETs also. Okay. And the second effect is the mobility reduction. So as the temperature is going to increase, the electrons will not move faster. Okay, so you can see mobility at a particular temperature is proportional to temperature power minus 3 by 2. So that the mobility is going to reduce in an exponential manner as the temperature is going to increase. T naught is the standard temperature where you measure the mobility, and T is the temperature at which you find the value of mobility. T naught room temperature, you might take it as 300 K. So at fixed bias, the drain current drops as temperature increases. So when the temperature is going to increase, mobility will decrease, and electrons are going to move. When temperature is increasing, mobility is decreasing. So when electrons are going to move with a very small velocity, then naturally how much the drain current value will also drop. So these are the effect on how temperature variation can affect your device. And last one, normal field mobility degradation. So mobility degradation, how what all mechanism can reduce the velocity of your charge carriers or pull down the value of mobility for your charge carriers. So as the gate potential increases, electrons are encouraged to flow close to the interface. Electrons always prefer the path with the least resistance. So initially they will be traveling in the middle of the channel. As you increase the voltage, they'll be attracted closer towards the voltage. As you increase the gate potential, electrons will be traveling close to the interface. So this is just like in the interface only. You will have all these covalent bonds. You have various ionic contaminants and abandoned regions. So when the electrons are going to flow through the region which has lot of irregularities, there will lead to scattering. Electrons will hit these particles and get scattered. So when electrons get scattered, that will reduce the mobility. When the mobility is going to reduce, the current will also drop. So obviously, mobility and current are related. See here, when the available drain current drops below the mobility, that is because of the decrease in mobility.